All right, this video is talking about applications of derivatives with trigonometry. So some of the things that we've already done, like looking at higher order derivatives, writing equations for normals and tangents, we're just going to do it with trigonometry examples so that we can practice. So one of the important things when you're looking at this, you have to know what this notation means. That is asking us to find the third derivative of this function. It's a little inconsistent actually with the way that this is given as f of x. So I would have expected this to ask us for f triple prime of x. So I'm going to rewrite that, but still good notation for us to recognize, but we should really be consistent with how they give us the problem. So the first derivative means take the derivative of sine x, which we know is cosine of x. The second derivative means I'm now taking the derivative of cosine, which we know is negative sine x. And the third derivative of this function is to take the derivative of negative sine x. Well, this is really negative 1 times sine x. The negative 1 is a constant, so it can come along for the ride, and then multiply that by the derivative of sine, which is cosine, so this is negative cosine x. They didn't ask us for the fourth derivative. Sometimes you see it written with these little mini Roman numerals here. But if they did, again, that's like the constant negative 1 being multiplied, so it can come along for the ride. We know that the derivative of cosine of x is negative sine x, so this actually gets us back to sine x. So it's a repeating pattern, which can be interesting for finding higher order sine or cosine derivatives. All right, we're being asked, again, notation not really matching, but to find the second derivative of this function. The first derivative is going to be one that you're going to remember. It's secant x tan x. And now to find the second derivative, I have to say, what's the big thing happening in here? Well, the big thing happening is multiplication, so I need the product rule. So first I am going to take the derivative, not take the derivative of secant. I am going to take the derivative of tangent plus, now I do take the derivative of secant, and I don't take the derivative of tangent. So that's the product rule. This simplifies to be secant cubed x plus secant x tan squared x. Okay. All right, again, same kinds of problems we've done before. It's just now we're using functions that have trigonometry. We're asked to write an equation of the tangent line. I know that in order to do that, I need a point, I need a slope. This is part of a point. It's pi over 3 as my x coordinate. To get the y coordinate, I need to find the cosecant of pi over 3, which happens to be equal to 2 root 3 over 3. So remind yourself about your unit circle. So now I have my point. To find the slope, I need to find the derivative, because that's the derivative of the curve. The derivative of cosecant is negative cosecant x cotangent x. And I need to evaluate that at the x value that I am interested in. So again, we have to make sure we remember our trig values. And this simplifies to be negative 2 over 3. So this is my slope. So I have a point, I have a slope. I'm going to use point slope form. It doesn't ask me to do any particular form, so this will actually be when I am done. All right, an equation of the normal. Well, in order to get the equation of the normal, I'm going to find the slope of the tangent and then take its opposite reciprocal, because a normal is perpendicular to that. In order to get the slope of the tangent, I'm going to take the derivative of my function. The big operation happening here in f of x is multiplication, so I need the product rule. So I do take the derivative of 3x squared. I don't take the derivative of cosine. Plus, now I don't take the derivative of 3x squared. I do take the derivative of cosine. All right, I'm going to evaluate this at negative pi over 2. So that's 6 times negative pi over 2. The cosine of negative pi over 2 is 0, plus 3 times x squared times the sine of negative pi over 2, which is negative 1. So this actually becomes positive 1 because it's the opposite of negative 1. This is negative 3 pi times 0. Well, that's just going to be 0. Plus, this becomes 3 pi squared over 4. And you can leave it like this. Pi is a number. If it doesn't it doesn't matter. It's not asking it for decimals or anything like that. So this is a perfectly fine value. And so this is the slope of the tangent at x equals negative pi over 2. So I want the slope of the normal, which is going to be the opposite reciprocal of that. So that's going to be negative 4 over 3 pi squared. So I have my slope. I need a point. To get a point, I need to take my x value and plug it into the original function. 3 times negative pi over 2 squared times the cosine of negative pi over 2. Well, the cosine of negative pi over 2 is 0, so this is just 0. So my point is going to be negative pi over 2, comma, 0. So I have y minus 0 is my slope times x minus the x coordinate, which is plus pi over 2. And now I am done.